Good afternoon, my name is Matthias Eckert. I'm from the University of the Algarve, and the title of my work is Evaluation of the Influence of Early Age Shrinkage on the Control of Mortar Cracking. The co-authors are Miguel Oliveira and Antonio Betancourt Ribeiro. In high-strength materials occurs micro and macro cracking, which facilitates the flow of liquid and gas into the concrete and attacks the reinforcement. This accelerates the deterioration of concrete and mortar, causing premature anomalies and reducing the lifetime of buildings. Microcracking occurs in any material that dries or cools not uniformly by diffusion of moisture or heat. Macrocracking is caused when the concrete elements are restrained by surrounding structures which inhibit the shrinkage. In practical terms, a superposition of both effects occurs. First, the microcracking takes place and later the macrocracking develops from the first. There are several types of shrinkage: plastic shrinkage, chemical shrinkage, autogenous shrinkage, thermal shrinkage, and drying shrinkage. Shrinkage is influenced by relative humidity, wind speed, and temperature. In this work it was tested the combined effect of expansive admixtures and set retarders in early age shrinkage evaluate and microstructural development in order to identify the influence of setting on the efficiency of the expansive action and crack proneness. It was prepared 7 compositions with different setting times. It was used 2 types of superplasticizers, called Sky and ACE, 1 set retarder and an expansive admixture based on calcium hydroxide formation. It was tested compressive strain, tensile strain, modulus of elasticity, chemical shrinkage, total shrinkage, and we performed the ring test to measure cracking. Here we have a crack example. The crack reached 7 mm. On this image we can see the side view of the crack. As expected, the set retarder increased the time period of the liquid phase due to delay of the development of solid structure. The setting time of Sky is much later than that of ACE. Mechanical properties. The compressive strength of the mixes with Sky are somewhat lower than that with ACE because of the high dosage of superplasticizer used, which retard the cement hydration. The same is not observed for the tensile strength and modulus of elasticity at the age of 2 days, which may be related with the effect of the expansive admixture. Expansive admixture improved the mechanical properties due to the reduction of water-bender ratio. Chemical shrinkage. The threshold may indicate the instant of beginning of a large formation of different hydration products, namely ettringite or portlandite. This threshold occurs earlier with higher amounts of expansive admixture because of a reduction of the water-bender ratio. Total shrinkage. Comparing the reference mixtures with the others, it can be seen that the expansive admixtures not only induces an initial expansion, but also decreases the long-term shrinkage. It can be concluded that the set retarder extends the expansionary phase for a longer period of time and delays the shrinkage development. This may lead to reduction of the cracking sensibility since the time period to reach the same shrinkage value is increased, which is important for tensile strength development. Cracking. By analyzing the ACE mixes, it can be seen that the shrinkage strain, the tensile stress, and the stress-strain ratio decreases with the setting time. This behavior can be explained by a larger expansive period developed due to higher setting time. Consequently, the higher setting time reduces the number of cracks and the crack area. ACE reference is an exception of this behavior because of the low elasticity modulus, which leads to higher stress relaxation. ACE 0.3% retarder never cracked because the low stress-strain ratio. This composition had the largest setting time of all ACE mixes. The trend of Sky mixes is not clear because the expansion was induced in the expansive phase. The number of microcracks tend to increase with the addition of expansive admixtures, particularly for the Sky mixtures, and decrease with the use of set retarder. Conclusions. It can be concluded that the set retarder and expansive admixture improved the free mechanical properties evaluated in this work, namely tensile strength, compressive strength, and modulus of elasticity. The expansive admixture lowered the shrinkage strain as expected, but the set retarder alone seems to increase it. Concerning the influence of setting times in the efficiency of expansive product, it can be concluded that the shorter the setting time, the higher is the expansion peak. Long setting times extend the expansive period and reduces shrinkage at later ages. This later effect minimizes the cracking tendency because it provides more time to develop the tensile strength. This was evidenced by the ACE 0.3% retarder, which never cracked in 2 tests and 3 rings made from each test. Additionally, with the other ACE mixes, the number of cracks and the crack area was conversely proportional to the setting time. The expansive admixtures increased the number of microcracks, but the set retarder produced an adverse effect, what can be explained by the microstructural development. The combination of expansive admixture and set retarder is a considerable alternative to conventional methods like shrinkage-reducing admixtures or fibers because it improves the mechanical properties and it is more economical. Thank you for your attention.